Okay, let's get started. Hopefully I'm sharing the right screen. Okay, we can start, and this is being recorded so everyone can refer back. Good afternoon. Today is going to be the last session that I will be covering in this semester. Hopefully there has been something useful for everyone depending on their projects. As I mentioned a few times, this is a course that is project-based, and every one of you are doing different things in NLP, in computer vision, in speech recognition. So you're doing many different tasks, but we have been trying to cover basically the topics and the tools that are commonly used about machine learning. And in this last workshop, we are going to cover a few tips about generally academic writing with more focus on writing a paper or a report that here we are encouraged to do so. Yeah, so without further ado, let's get started. Oh, okay. I think many of us might have been in this situation before, that you are trying to write something, you're trying to basically transfer your thoughts into your computer on a paper, wherever that is, and you might become frustrated. You think writing is the most, specifically academic writing is the most difficult task in the world. You might think initially that you have everything on your mind. You know what you have run, for example, here a lot of experiments. You have implemented your model, your method, and you have got some good results. You're like, okay, I have done everything in this project. I know everything in my mind. So it should be easy. But then when you start, you feel like you cannot transfer your thoughts easily to the computer, and you try to basically say yourself right, and nothing comes out. I think that might be that the academic writing might look difficult if you are not following any sort of structure, any sort of standard process, customized process. But while you know how to start, where to start, it actually looks easier. So just a quick note, the things that we're going to talk about, we're going to talk about like processes, how to start from brainstorming, get to good writing. Most of you might already have a process for yourself, a personalized process that works. You have been writing a lot, or you might have even received good feedback. You might have done a project. You might have contributed in a published work in a paper. So if you're at that stage that you feel like you can start from 0 to 100 and you get good feedback, you have a process in place, then you don't need to make a lot of adjustments. But we are trying to provide like a process that makes things easy in general, but I believe everyone can modify and personalize that depending on the task also, but also depending on personal preferences. So the things that we're going to talk about are best practices in academic writing, plus a bit of personal experience on how to do things and how to write things that works better, turns out, gives a better results based on some research on some personal experience. It's saying that there's no golden rule, as I mentioned, that works for everyone. I think it's always better to to take these best practices and like the processes that everyone talk about and modify that a little bit to your personal adjustments and to your personal preferences. Excuse me. So let's get to academic writing. Let's first define what is academic writing. Why do we need to write? You might think it's the only purpose should be to present your thoughts to others. That's true, but that's not the whole story. Yes, sometimes you need to write here reports, for example. Sometimes you need to write papers, books to present your works to others. But writing has also been proven to be helpful to yourself, the person's himself or herself most of the time as well. Because when you write, you think more deeply about what you're writing. And you actually need to develop this skill of being critical to yourself. So as you write, you think about it, you question the things that you write. Especially, again, we are talking about academic writing, which we are going to see is a little bit different with writing essays or other things. So in academic writing, when you do writing, you most of the times think more deeply, you see more, some of the details that you haven't seen when you were thinking about them before the writing, or you might even discover new phenomena. You might come up with new ideas when you write. So it's not just for communicating with others, but it also helps you to write. So it's good to know how to write properly, how to have a working system or process in place for academic writing. It's surprisingly powerful, I would say, and helps you better read and judge, be a judge of your own work. So that's a skill that comes with writing. There are many works out there that could help you find out what is the best way of writing. So there's an example here that you might also find it suggested on the university's website. But reading about how to write is one thing, but the fact is that writing is a skill, and as like many other skills, perfection comes with practice, right? The more you practice, the better you become at it. You need to practice a lot in order to learn how to do it properly. So this is key that we shouldn't forget. Many of the things that you talk about, for example, I don't know, many of the academic, many of the things that you learn, you can just read and learn and like imagine. But we should note that writing is a skill that you can basically attend this, for example, workshop. You can read a few pages of blogs or a few pages of books, but at the end of the day, you need to practice to make sure that you know how to do it. The other thing that is very important in general is that a good piece of work doesn't happen in one go. Most of the times, if you see a very clear paper, a very nice piece of work, a very clear report that you just enjoy reading, that's a result of multiple iterations and revisions. So that's something that is very common. Normally, I'm not saying 100%, but normally it's very rare that you write something in one go from 0 to 100. And then you read and you enjoy. There's most of the times a lot of revisions and iterations needed to get to that point. And the key to improvement while you're doing your revisions, and this is another skill that I briefly mentioned, is that you need to learn how to be critical. You need to learn that you need to play two roles, basically. You need to be the writer, and also you need to be a reader. And when you are on the role of the reader, you need to forget about your biases. Try to be a different person, try to look fresh, try to basically be critical and question all the things that you're talking about, you have written yourself. It's only when you are critical of your work is that you find the flaws and you can improve yourself. So this is very important in academic writing, because when you write, you need to be convincing. And if you cannot convince yourself, most of the times it means that you might not be able to convince others either. In that sense, it's not always possible to basically be a totally different person while you're reading. And it always helps to seek feedback and have fresh viewpoints on your work. So someone as your peer or as your supervisor might have a look at your produced work, whether it is a report, paper, draft, whatever it is, and they know the concepts, but they have not done the experiments. They have not implemented everything, so they don't know a lot of details. But when they read it with their fresh point, without a lot of biases that you might have, they see a few things that you might have read basically the draft a couple of times and you haven't noticed. So it's always good to, excuse me, first learn how to be critical to your work, but then at the end of the day, you need to seek feedback as well in order to basically write something that is almost flawless. Now, the things that we need to be clear about is that academic writing is different. What is the difference? The main difference is that, for example, if you're comparing with essays or artistic pieces of work, you're not just trying to send a message to basically, or make a statement or basically talk about something that has happened in the past. Most of the times you're writing to communicate ideas, and those ideas need to be convincing. You need to convince the reader. So you have, your tool is the words that you write without having a chance of seeing the person who is reading. And based on your words, I mean, it might be easier to convince someone when you're talking face to face, right? Someone might ask questions and you might have answers, but it's important while you write. The fact is that there's no chance for the reader to ask questions. So you need to be able to predict those questions and have answers in your text that are convincing. In that sense, it's full of arguments, and those arguments need to be supported. Claims that look unsupported most of the times raise questions. And in academia, if someone raises questions about your writing and you don't have an answer for it, that's normally not a great thing. So if you make arguments, you need to make sure that they are somehow supported. Now, there are many ways to support your arguments. You might use logical reasoning. You might have evidence and experiments. For example, let's say you have trained a neural network and you put the training and the validation curve, and you refer the reader saying that just by looking at that curve, we can see that we have overfitting, right? If you're, for example, want to claim that you have an overfitting problem and your paper or your report wants to solve that problem. So if you just say randomly, oh, we know that our model is overfitting, everyone would question that. Everyone would be like, how do you know that? And is there any basically supportive evidence? So that's what I'm talking about. Or sometimes if you're proposing a new method, part of it could be supported by referencing to other works, other papers, other books. Part of it needs to be mathematically proved. So it's always the takeaway message is that you cannot basically use an example that we have here. For example, I believe I have done this and I've got this results. Or I believe I have observed that phenomenon, for example, overfitting. Or I believe I have learned X by doing this experiments. And those things normally are very hand wavy. You need to have, when you have these sort of arguments and claims, you need to support them with different tools that I mentioned here. So like a bigger picture difference with non-academic writing, for example, an essay, you might have an introduction, you might have body paragraphs and conclusion. There's no clear sections, there's no clear structure. For example, when you're talking about a report or a paper here, you might have introduction method. Now we're going to see the common important sections. Of course, based on your task, based on your problem, you might add, remove sections. But there are like, how do you say that? There are fairly standard structures that everyone would adjust those structures. So they wouldn't revolutionize those structures. No, most of the times, we should have an abstract introduction. We should have a part that we discuss the method. We should have a section that we discuss the results, and we should have a conclusion. So those structures exist, unlike other types of writing. As I mentioned, the arguments or the things that we write about are based on evidence, based on some support, some sort of support. The writing is formal. Most of the times we cannot be informal. I mean, 100% of the times we cannot be informal. It's better to always be formal. We cannot be subjective. We cannot talk about our emotion. We cannot talk about our thoughts. We cannot talk about what we believe is true. We need to have basically a clear objective when we are writing things, and we need to basically support those objectives. Need to be balanced as well. We cannot be biased towards one idea or the other. We cannot just clearly say, okay, ResNets are the best CNNs in the world. We need to basically support support those arguments. We need to compare them with different methods, and we need to show the reader that if we are claiming ResNet is the best, just as a random example, we need to show the reader that it is the best rather than saying, oh, I think it's the best. And we need to be precise. We cannot say the results that we got, we have got roughly 50 to 60% accuracy on that task. No, we need to be 52.56, whatever that is. We need to be precise about everything. So these are the main differences when you're talking about academic writing for and it's very important. You might already be familiar with this again, but I thought it's good to review, and it's good to know what we are trying to achieve here. Now, if you want to put like a standard process, as I mentioned, this is something that you can see is suggested in best practices in many different resources. And it works most of the times with a little bit of basically your own flavor of salt, pinch of salt and pepper, whatever you want to call it, with a little bit of modification, personalization. This gives you a good basically process that if you follow, you make sure that your writing is adhering to the standards that it needs to. So everything starts with brainstorming. I think it's very necessary, both based on personal experience and based on basically whatever best practices that you find papers about how to write a good paper. Brainstorming is very necessary because you need to do that to think clearly, to basically have like a high level, big picture idea of what you want to include, what you want to talk about. And those what's that we're talking about here are what sections and what subsections. So for example, if you're talking about this report here, you need to start thinking about introduction, method, results, conclusion, those big high level sections, and maybe subsections based on your task. You might have in your method, you might brainstorm and think, okay, my method involves extracting those visual features or extracting those word embeddings and then feeding them to a neural network. So I need to talk about these different subsections. So it's very important to draft that big picture of your document first. And then after like defining the sections and subsections, maybe in one sentence, maybe in a few words, define or write down the message that you want to send in that section. For example, in the introduction, I want to say that I have run these 10 different experiments, and or first of all, we get to that section of what introduction is, but like as an example, you want to quickly write about, okay, I want to say detecting rubbish. Sorry if this is a specific example of someone's work, but this is just a random example that came to my mind. You might want to think, okay, detecting a rubbish, for example, using your computer vision techniques by cameras is important because we can then put those cameras on the rubbish collection, for example, vehicles, and we could automate that process. So importance of rubbish collection, for example. And then the method you want to talk about, for example, I used ResNet again, because ResNet is very popularly known by everyone. I used ResNet and I did this modification. So a few words of what should be included in this section, in each section. Again, we were talking about introduction. At the end, we got these results. Normally people get 85. I got 90% by these small tricks, for example, dot augmentation, whatever. So start with the big picture of sections, subsections, add a few words of sentences of what should be included, what should be the main message that you want to send, and what are the key ideas of, for example, if you're talking about the method part, what are the key ideas? What are the main differences of your work? What are the basically the main tools, the main approaches that you have maybe combined? For example, I have used glove embedding, I have used BERT, and this is how each of them works. In your experiments, you want to talk about what experiments you ran and what results you got. So maybe you want to write 3, 4, 5, whatever number of experiments that you think are important. They show the improvement that you have got over the baselines, for example. And in related work, maybe while you're doing your brainstorming, while you're making the first draft, you want to write, okay, I want to talk about paper A, paper B, paper C, so that you have a clear picture of how those papers are related to your method. So after you have done this brainstorming, you can start expanding those sentences, words that you wrote about each section. And while you are doing this, it's very important that you need to fully explain all the details that are necessary, all the things that come to your mind. Don't limit yourself. I have seen some people sometimes they say, okay, I know that at the end of the day, this section that I'm talking about, it needs to be half a page. So I'll try to just limit everything to half a page. From experience, it's normally better to write as much as you can, include everything that is necessary, because it's always easier to reduce and summarize something that you have written rather than expanding it. Because on the other side is that you write 1-2 pages or 1-2 sentences, 5 sentences, and then you come back and you see, okay, I need to get 6 pages. I don't have enough content. Expanding it might become more difficult. Whereas if you have written everything, and if at the end you come back and you see it's too much, you can easily summarize it. So start expanding things, explain about all these concepts, all these keywords that you have written while doing the brainstorming. And then normally it's a better practice to leave abstract and introduction, writing it for the end of the work. And again, we are going to see what are the normal standard contents of abstract and introduction. But why should it be left for the rest? For the last step is that abstract and introduction give the reader an overview of what you are talking about in the full document. So it gives a reader the ability to see what to expect from the full document, and what other contributions, what is the work that you are doing, why is it important, and what you have done and what results you have got. Those are the things that in summary should be included in the introduction and abstract. So it really depends on what method you will talk about, what experiments you have done, what ablation studies, if you have any comparison. So it's because it's an overview of all those sections, it might be a better practice to write all of them, and then based on those, find a good story, put everything together in a proper flow of information, and then put that into abstract and introduction. And as I mentioned, if you have done this, then you will have the first version. And most of the times it needs at least a few iterations. Edit, revise, read again. And then the last step that I would suggest to do is to check for grammar and spelling. So it could be as simple as putting it on one of those tools that are available online, like Grammarly, to check. But we all know that they are not also sometimes perfect, specifically the free version. Sometimes they might not be perfect. So it's up to you how do you want to do it. But after your text is complete, after all the experiments are in there, after the message is properly conveyed, after you're happy with the content, now it's time to check for grammar. Because if you do it before, then because you're revising your work, you're checking everything again and again. You need to redo it again and again. So that's why it makes sense to put it for the last step, because if the content, you're happy with the content 100%, now you can just make sure that the grammar, spelling is correct, punctuation is correct, for example, all those things that are very important. So I've put a screenshot of the discussion on the forum here for your reference. If you haven't seen that, we have clear expectations about this report, about the general structure. Now I would like to emphasize that this is just, you can think of it as minimum requirement. It doesn't guarantee 100% score if you just include these things, because it really depends on what your task, what your project is, and what needs to be included. But these are the main important things that shouldn't be missed, I would say. So we need to have an abstract, introduction, related work. One thing that I would note here right away is that, and something that I have come across a lot of times, is that in related works, sometimes people just list a bunch of papers like a laundry list. It lists a bunch of names and maybe author names, titles, and then they just maybe copy and paste a part of the abstract and introduction of that paper. Now, that's not really the purpose of related work. The purpose of related work is basically related work needs to come from your thoughts. It's what you understand from other works and how they are related to your work in a specific. And when you're talking about other works, you are not just saying, hey, for example, in 2014, 15, whatever that date was, ResNet was introduced and the authors introduced residual connections. Well, that's good that you're talking about what ResNet is about, but the reason that you're talking about ResNet here in your related work, there should be a clear reason for that. For example, for example, you could come up with something like, we have introduced a new architecture that compared to ResNet that does this X, Y, Z and has problems of A, B, C. We don't have those problems. You have solved those problems. So it should be clear why you're talking about something and what they have done and how they compare with your work and with other works. That's really the purpose of related work. Now going a little bit deeper in every one of these sections. First of all, again, it's recommended to put your work on the on a template of one of these big conferences, CVPR or ICCV. I believe they should have very similar templates like the ones that we can see on the right-hand side. It's a double column, basically structure, and you could see that it starts with abstract introduction. On the top, you have the title, and on the bottom, you have the names of the authors and everything. So these are not set in stone. Again, I mean the name of the authors, the title. But if you follow these, the sections are very important that we're going to talk about. But if you follow these, make sure that you stick to this kind of a structure. And we have mentioned a few times, if you want to find out about what is a good piece of work, good examples are the basically award winners at these big conferences. Now, this paper that I've put here, basically the topic or the content is not really important, as it was the award winner in last CVPR. CVPR is the big, basically the biggest computer vision conference. It doesn't say the fact that it won the award was because of many different things, right? Because of the good results, because it was written very well, because it was outstanding work in many aspects, but it doesn't say that it was perfect in writing. But it gives you a good example of how should you structure your work and how should you write to convince people that you are a good work, right? If they were able to convince the reviewers that they are outstanding, it means that they have done a good job. So it could be something reliable, but you could find similar papers, normally highly cited ones in these big conferences. Those are the factors that suggest that piece of work is basically has a lot to learn from. So in terms of the length, abstract and introduction, so speaking of abstract, it needs to be roughly, you can see here they have, like in this 2-column structure, they have half of one column, almost half of one column. Normally between 50% of that single column to 75%. By the way, here CVPR is 8 pages of writing. And I believe your report has to be between 6 to 8 pages as well. So roughly the same structure you could follow. Between 0.5 to 75% of a full column normally should be allocated for the abstract. Anything longer than that, it's not really the abstract, right? Abstract should be short and concise. Anything shorter than that might suggest that you don't have a lot of content. So not all the times, again, task by task might be different. You might have good reasons to go. It's hard to find a good reasons to go beyond that, but you might be able to find 40% of the single column would work for you, right? That's what I'm trying to say. These are the average, basically, numbers that would work for most of the times. The purpose of the abstract, as I said, it's very important to say what the problem is that you're trying to solve. So in a few sentences, maybe 1 or 2 sentences, you want to say, for example, I'm talking about finding the best speech recognition model among the ones that are available. You want to say the problem is speech recognition, for example, on I don't know, news speech data that was recorded from news. So you want to clearly say what your problem is. You want to clearly say why your problem is important and challenging. Again, every one of these is very short, 1, 2, 3 max sentences. And you want to mention how you solve it without the details. For example, I propose this new architecture. I propose this new training objective. I propose this new data set, whatever that is. How you solved it and what resource contributions you had at the end. So you can quickly say, for example, and based on the experiments that we run, we have observed, for example, if we use, we have observed that if we use a simple baseline of ResNet, simple baseline of BERT, simple baseline of wave to wave, whatever your method is, simple baseline of method X, and we have done all these experiments and we have observed 5% improvement in the results. So you want to give a very quick overview message of what your problem is, why is it important, how you solve it, and what results you got. This gives you a big picture of your whole 8-paper, 6-paper report in a few sentences. And it needs to be able to it needs to be motivating enough for the reader to go and read everything else. The purpose of introduction, you can think of it as a little bit longer version of the same thing. But you need to expand more about every parts of the abstract. So you can expand basically the motivation behind the problem. You can start a little bit further away of saying what the problem is. For example, if you're talking about classification of diseases, you can start with providing some numbers on why you think using computer vision or machine learning is important for disease prediction. For example, if you do this, if you automate this, you might save X amount of money. So you might start motivating the problem, saying that this is a big problem and this is challenging, and then you introduce your method. Now, when you say in the introduction, you don't need to and you shouldn't go into the details of your method, right? You just need to motivate the reader, introduce them to the method, excuse me, and motivate them to read, to actually go to the section, right? It's just basically like seeding the reader. Just give them a little bit or an overview, a rough understanding of what you are trying to do, a bigger picture, and with a little bit of detail, not too much, so that there is more details in the section that they can refer to. In terms of length, it's normally 1.5 to 2 of these columns. So imagine if you start from the top, if there was no abstract, you could go all the way to here, having 1 column and half of it, or you could go all the way to end of second column, a little bit less or more. That's normally a good size of having an introduction, and then that's divided between all these different things that we talked about. So again, this is based on the fact that you have 6 to 8 pages of contents. Now, if you feel like you have, I mean, that's a requirement, right? But for any reason, if you end up with 4 pages, it's better to adjust everything accordingly, right? It wouldn't look good if you have 2 pages of abstract and then 1 page of introduction, and then you go and read the method is a few sentences. So everything is kind of relative to the 6 to 8 page that we're talking about. Related work. I briefly mentioned that there are a few things that you need to watch out when you're writing related work sections. First of all, in terms of length, again, it depends on how many things, different papers, different works you're comparing your work with. But on the right hand side, you could see the related work section of the same paper. You could see it has even a smaller subsections when they talk about specific things, a few different areas of research. The purpose here, as I mentioned, is that it's not just to name the papers, but basically to summarize their claims, their findings, without the reader need to refer to those papers, right? You need to tell the reader what that paper is about, what they are doing, what they have proposed. And if the reader needs to know the details of those papers, yes, they need to refer to that, but otherwise they need to basically get that understanding of what that paper is and what your work is and how they compare. Or if you're talking about different pieces of works, different papers, you need to show the reader how they're connected. For example, ResNet was expanded by ResNext, by that architecture, that improvement, which gave us that much of results. Now we are expanding ResNext with another attention layer, for example, and that's how these works are connected together, right? It's very important to just not list items, but also from your own words, from your own paraphrasation, talk about their findings and clearly analyze and compare with your work and the other work. So if you look of it from high level view, a big picture, that related work should give the reader basically the picture of the status space of different works that are related to your work and how they are related. That's the message. Moving to the methods section, you need to explain your method in full details in a self-contained way. So the method should have enough details that the reader doesn't need to read other papers or other works in order to understand what you're proposing here. It should have enough details. In terms of length, it really depends on what your problem is and what your method is. Sometimes it's 2 full columns. Sometimes it's more than that. And you need to make sure that you include all the mathematical equations, definitions, and all those kind of things. Now, a few notes on talking about math and basically definition equations. They should be numbered. You could see here that they are numbered. You should avoid, I've seen sometimes people use screenshots of other papers for math to avoid writing. Well, that doesn't look good, to be honest. The font is different. The size of the font is different. And it is clear that it's a screenshot. You can't put numbers easily on it, especially if you're using LaTeX that we're going to see. LaTeX. So avoid those things, and every variable should be defined. So when you put an equation or a mathematical basically statement here, you need to, in the next immediate sentence, you need to define all the variables if you haven't done before. So in this text, for example, just regardless of the fact that what these values are, g theta is RLX multiplied by RLD, whatever that is. You see right away they start where M6, M theta, whatever those are the dimensionalities of the latent codes. So if everything else is clear what they are in the previous sentences, in the immediate sentences following an equation, everything should be clear. So basically, up to this point, up to the end of this paragraph, having checked the equation and having read the few sentences afterwards, maybe sometimes a few sentences before that, I should be able to understand this equation and all the variables. I shouldn't be able to tell you as a reader what this R is, what LX is, if they are not previously defined. Right after the equation, they should be defined. So these are good practices. Sometimes people just put an equation and they assume, for example, X and Y are always X is the input, Y is the output. No, we can't make those assumptions. Every variable that is put here needs to be defined somewhere. And it's better to define that right away after the equations. Or if you have done it before, you can assume that the reader is following the overall flow. Reader has started reading the method from the beginning. So as long as you have that in the method, if the reader starts from the beginning to the end of the methods, if they understand, if they know all the variables, they will define that fine. The experiment. So the results, you want to call it the experiment section. The content is very similar. The naming is another one of those things that you can adjust. For example, for example, you can talk about the method, and then you can have subsections of glove embedding. What is glove embedding? BERT, what is BERT, all those things, right? Sorry if I'm saying the specific examples of NLP and vision and your project is a little bit different. I'll try to maximize the diversity. Okay, so the purpose of this part is for the reader to be able to re-implement and reproduce your results. It's very important, right? If I'm reading your report, your paper, if I'm checking these parts, I should be able to look at your paper, and on the other screen, on the other side, I should be able to, as I read, implement your method with all the hyperparameters, with all the details of implementation. If you have used, for example, PyTorch, you have implemented that on PyTorch. You could say I've used PyTorch, I've used all these things. These are the hyperparameters. These are how you could have a figure if you're talking about a neural network architecture of putting how everything is connected, so that I should be able to look at your text and figures in this section, or the figures could be in the method section as well. The details of implementation are important to be here, and the hyperparameters and all those stuff. Learning rate. There are a lot of things, right? I should be able to check those and implement and rerun your experiments, reproduce the same results. If you got 88% accuracy, I should be able to do that on my own by reading your experiment section. So think of it that way, and make sure that everything that is in the code that is important, without the need to put a screenshots of the code, right? It's normally if parts of the for the screenshots of the code refer to the page, refer to the assignments web page and the discussions. If there is any part that asks you clearly to put the screenshots of the code, that's fine. I'm talking here more of a paper, and these are applicable to the report. But if you don't have to, and if you haven't put the screenshot of the code, then I should be able to read and re-implement. Length, it depends on what you have done. It could be 2 columns, 3 columns, 4 columns of full text, and including of the details, as I mentioned. Details of the dataset are very important. If you're talking about a dataset that the split is not public, is not available, even if it is public, you need to provide all the details. But if it is not public dataset, if it is something that you have annotated, you have collected, it's even more important to put all those results of details of the size of the dataset. For example, you have 100 overall some number of samples, and you have divided that between 75 training, 25 validation. Now in testing, you should have testing as well, just random examples. And you should provide, if you're talking about classification, you should provide a distribution of the classification, because otherwise, if those details are not clear, the results that you're suggesting might not be clear. I think I've had this example before while we were talking about metrics, that in your testing set, for example, you might only have one class. All of the samples you have might come from one class based on an unlucky random sampling that you have had, or maybe you have made introduced a bug or something, and then you're getting 100% test results. Well, if I see that, or if anyone would see that 100%, they would be first impressed, yes, but then they might also try to see if that result makes sense. And if that doesn't make sense, and those results, those distribution of classes, for example, are not available, it might be hard to see that. So it's good to clearly talk about a data set, make it clear what data set you have, what is your training size, what is your testing validation size, and more details that makes it clear how you achieve the result. If you're talking about a specific experiment, for example, changing a hyperparameter, you should start with explaining and having an intuition, at least, that says why you are trying to run that experiment. For example, before running the experiment, you might think, okay, based on the observation that the training is going very slow, I think the learning rate, I understand this is not right. Normally, you would put the results after you have done all this hyperparameter tuning, but let's assume that that's an important part of your report that you want to report on, and you want to say why you run that experiment, for example, increasing the learning rate. So you can say, based on the training curve that we can see, the training is very slow. So we realized that, for example, we need a better learning rate scheduler. Just an example. And then, as I mentioned, hyperparameters. And after the experiments, it's also important to analyze the results. So you can say, now we can observe in the graph that is provided that using a tri-stage learning rate scheduler was better than a linear decay of the learning rate. And we can see that the training has improved. The training curve has improved. We have got better results. So it's good to have reasons on why you're running an experiment and analysis of what you have seen and learned from that experiment. Okay, when it comes to figures and tables, first of all, they are most of the times a necessary part of your report and your paper. And when it comes to those, it's very important that figures and tables should be clear and by themselves independently, standing alone, should send a clear message to the reader. They should have, in that sense, they should have clear captions that tells the reader what those figures and tables are showing. If there is any, for example, abbreviations that you have used, if there is anything that needs to be defined, you can define that in the captions. And again, it's better to implement them and draw the tables and not the figures. Figures sometimes you get from your basically code, but it's better to draw the tables rather than the screenshots where necessary, where possible. In figures, most of the times people might forget about axis labels and they assume everyone knows. For example, if you're talking about training curve, X is, for example, the steps during the training, the epochs, and Y is, for example, the accuracy or is the loss. We can't assume that everyone knows that, right? We need to clearly define the axis with a consistent font size and figure size. I've put examples of the same paper, for example, the award winner paper, to see what a good figure and a table means. Sometimes you might need to expand the table to the full column. That's also possible. Don't if you have very wide tables, don't feel obligated to use only a single column. It's possible to use the full column. But if that's the case, normally that should go on the top of the page. So you can see that the figures are clearly explained, the fonts are consistent, the figure sizes are easily readable, even in the original size, although the reader should zoom in, should be able to, can zoom in, and these figures should be clear enough while zooming in as well. So it's clear. If you read the captions without going into the text, you can see what the picture is showing and what your purpose of showing that picture is, right? Even more important than the fact that what this figure is showing is more important than that is what you are trying to tell the reader from putting this figure here. For example, you are trying to say our method is getting better results from the table, or your method's predictions on the right hand side, you are trying to compare you with previous predictions, and you say our predictions are less blurry. And the message should be clear. And at the end comes, now these were the standard ones. You might add or remove. I would suggest we might add, not remove, but change the names, those kind of stuff. And then you will need to have the conclusion, and the purpose of the conclusion is a little bit different with abstract and introduction, right? You assume that abstract and introduction are introducing the reader before the reader has read the text, whereas here you can kind of look at it from the perspective of the fact that reader has gone through the whole paper. Now you want to give a takeaway message to the reader of what your paper was, what the reader saw, or even sometimes the reviewer, the reader, the marker might not check all the details, and they might check the conclusion. So it should be more clear in the conclusion of what you showed in terms of the method and experiments in the whole document. So as it comes at the end, it also comes with the perspective of the fact that you're now looking from the bottom of the paper, from the end of the paper to the whole paper, specifically the experiments and methods, and you want to give the reader a takeaway message of what you did and what you achieved. So So please check the assignments page for the report. If you haven't, there are specific marking criteria that you could see in terms of the length, at least 6 pages, spelling, grammar, and layout. If you follow those, basically the layout or structure that we talked about, very similar to like a CVPR paper, you should be able to, if you assuming that you have good content, you should be able to achieve these marks. And all the discussions that are necessary, you could adjust the sections. And I didn't talk about the references. Of course, don't forget that after all these things, at the end goes the references and the citations that you have made. In terms of the tool, you might want to go with an easier tool like Word, but it's not very popular in academic writing, especially in our field, because of the limitations that it has. And of course, we are all computer scientists or software engineers or computer sciences students. So it's easier for us to just use code, and LaTeX provides a good platform for coding the writing, coding the math, coding the structure. It's very easier to use LaTeX, and it looks more professional. If you just compare the output of Word and LaTeX, it's clear with a single view which one you have used. And so in that sense, it's recommended to use LaTeX, and a good tool, free online, that you can also share between a few writers are now here. You might not need it, but in general, is Overleaf, and it's basically something that you have, it's over the cloud, right? From your different devices, you can have access, and you can just write your paper and update that using LaTeX, which gives you a lot better results at the end. Now, the last section that we're going to talk about is a few tips summarizing what we have talked and a few observations that we have made before. In terms of clarity and structure of writing, make sure all the related sections with modification based on your task, right? Check the assignment page, check the discussion forum, make sure all these sections are included. And we talked about the important ones and what they should come with. And the other thing that you need to make sure during the revision, specifically after you have this second version, is to read the whole section flow, from what section to what section, from what subsection to the next subsection, and see if they are properly ordered, if the writing is connected. If you're talking about, for example, if you are first talking about an objective and then introducing your, let's assume your loss function, your objective has 2-3 different parts. If you first introduce the whole objective and then you go through every single part, it might not be clear. It might be more clear to have subsections for every single part of the objective, and then show the final objective, say this is the sum of all those things, just as an example. So make sure that if a reader follows the structure, the sections are clearly connected. As I mentioned, make sure you do the grammar wording check at the end. Correct use of pronouns is very important. Correct terminology, network architecture versus structure. Now it's more common to say architecture, at least in our field. Sometimes people who are from other fields, they call it the structure. Just an example, but make sure the terminologies that you use are actually standard things that you would see on the papers. Make sure all the previous works that are related are properly cited. Now, when it comes to citation references, I would like to note that it's not for the related work. We saw that in that paper, right? All over the paper, not just this related work. In the introduction, in the related work, of course, in the method, you would see those citations, references. So wherever you're referring to someone else's work, make sure that that's cited. Now, you should also avoid oversighting, right? If you're talking about something in 2-3 different sentences, you don't need to recite that every time. And make sure any argument that you make, any improvement, any observation from experiments has enough support. And if it is based on other previous findings, it has a citation. And at the end, the papers that you cite are very important. They also talk about your work because you're saying your work is connected to them. So if your work is connected to some work that um, is not cited after 10 years, it hasn't got a single citation, or there are clear flaws in that, it's not a great thing as a personal advice. So you want to connect yourself with the good works, with the non-works. Of course, you don't want to fake the connection, right? What I'm trying to say is that when you pick citations, when you pick the papers that you want to talk about, among the related ones, the ones that are clearly accepted by the community are better ones. The other thing that you might sometimes dismiss is that you need to define abbreviations before using them, using capital letters, right? If you're talking about convolutional neural networks, you can use CNNs, but with the first time that you use that in your text, if it is in the abstract, you need to define that. You need to say convolutional neural networks, parentheses, brackets, CNNs. And then every time all over your text, you can use CNNs. You don't need to go back and say convolutional neural networks. But for the first time that the reader reads something, that abbreviation needs to be defined. And as I mentioned a few times, while you're reading, be critical. Question the arguments that you make and think of it, think if they make sense, if there's enough support. And polish again. It's only after a few iterations that you would see near perfect works. And I can't emphasize more on the checking this spelling and grammar and punctuation. Believe me that for the first time, you're going to make those mistakes, rather small typos or forgetting about punctuations, because, and that's the purpose of the process that we saw, right? In the very first steps of brainstorming, writing the only the key points, expanding them, you shouldn't care about your grammar, spelling, all those things at all, because you can't focus on many things at the same time. You need to focus on the content. After you make sure the content is correct, you can come back at the end and check the grammar and everything else. It's always, as the last point, it's always very good, and I think we are fine with the timing as well. It's going to be a few 1 or 2 minutes. It's very good to, now that you have written your text, let's assume this is your own 1, 2, 3, 4, 5, 6, 7, 8 pages that you see on the top. Oops. So it's good to zoom out and see the big picture. There are studies on what are good papers that apply to a good report as well, right? If I'm someone who wants to spend, let's say, 1 minute on your paper or 2 minutes on your paper, on your whole report, what I would do, I would quickly maybe check the abstract, maybe skim through the abstract, look at the whole paper, skip the paper. Now, I'm not saying that I will be doing that, but I'm saying that you should have something for those kind of people, because that's the first impression. That's very important. If someone wants to look at 2 sentences, what I was saying, that they would check skim the abstract quickly, check the figures, check the tables, check the mathematical equations quickly, everything that can be understood quickly, and they go through all your paper, 8 pages in 2 minutes. Then what you would have to suggest that you have good content based on the studies and based on just human nature, right? If you have good mathematical expressions with good explanations, if you have good figures, colorful figures that give the reader a big picture of your method, your data set, your task, your problem, then that shows a good piece of work that motivates people to go deeper and deeper and read your work. Of course, we can't fake those things. It's also going to be obvious if you're just trying to add more figures randomly. You add redundancies, you add the things that are not necessary. But there should be always figures, tables, and sometimes math. Now, this is not a math intensive report, I understand that. But you might not putting too much emphasis on the math side. Figures and tables, it will give a lot better look to your report and to your paper if you have them at their appropriate location with appropriate and basically clear wording captions, so that the reader can skip through in 1 or 2 minutes, your whole paper or your whole report and build a big picture of what your problem is, how you have solved it, what results you have got, and if you have spent enough time on your report or not. That's kind of the last suggestion. And don't forget that every task and problem is unique, and make adjustments, as I mentioned many times, to what we reviewed as necessary. But thank you very much for watching this workshop and attending all the previous ones. And I hope you have enjoyed this course, the workshops, and best of luck with the rest of your course and best of your program, whatever that is that you're doing. Thank you very much, and see you next time.